So we're going to learn about 4.9 antiderivatives, or the inverse operation of differentiation. So instead of finding f prime of x from f of x, we're going to find f of x from f prime of x. So we're just going to compare derivative and antiderivative. For derivative, we pull down n and we multiply by the constant, and then we subtract 1 from n. But for our antiderivative, we have to add 1 instead of subtracting 1, and then we have to divide it by n instead of multiplying by n. So this cancels out, and then negative 1 plus 1 is 0. So it's c times x to the n plus c. And this c right here is constant. And we have to put constant at the end because derivative of constant is 0. So let's look at an example right here. So f of x equals x cubed. So the derivative would be, we pull down 3, so 3x, and then we subtract 1, so it's squared. But for antiderivative, we're given f prime of x, which is 5x to the 6th. So we have to find f of x. So now we have to add 1, so 6 plus 1, and then constant divided by n, which is 6 plus 1, which is going to be 5 over 7 times x to 7. And then we have to add c at the end. For antiderivatives of trig and inverse trig, we have to know what we learned from the last chapter, which is derivative of trig and inverse trig. So all of these are just basically the opposite, or the vice versa, of derivatives of trig and inverse trig. For example, derivative of sine x is cosine x. So for antiderivative of cosine x equals sine of x plus c, it's just the opposite of this. But for all of these, we have to add c at the end. So we're just going to apply this to a question. So we're given that f prime of x equals cosine theta plus cosine theta times tangent squared theta all over secant squared theta. So I'm just going to pull out cosine theta. So it's 1 plus tangent squared theta all over secant squared theta. And now we're just going to use our trig identity we know. So 1 plus tangent squared theta is secant squared theta. So we're just going to cancel this out. So f prime of x is cosine theta. And we have to find the antiderivative of cosine theta. So f of x equals sine theta, and then plus c. So we're just gonna use another trick we know. So antiderivative of is this s looking symbol right here. It's just gonna apply to these two functions. So it's gonna be antiderivative of f of x plus antiderivative of g of x. So for this example, it's going to be antiderivative of 3x fifth plus antiderivative of 2x to the 8th. So it's going to be the same thing. So 5 plus 1, which is 6, and then 3 over n, which is 6, plus 2x, and then add 1, so it's x to 9, and then 2 over n, which is 9. It's going to be 1/2 x to the 6th plus 2 9 x to the 9. And this is going to be f of x. So for derivative of ln x is 1 over x, which we already know. So we're just going to work backwards. So it's going to be like this way. So antiderivative of 1 over x equals ln x plus c. We cannot forget about c over here. And for this one also, derivative of e to the x is the same thing, e to the x. So when you work the opposite way, antiderivative of e to the x will be e to the x plus c. So for this example, I'm just going to apply to these two. So antiderivative of e to the x is the same things, so it's e to the x, and then plus antiderivative of 1 over x, which is ln x. So now we're just going to look at antiderivative of f double prime. So it's going to be the same thing, but from f double prime to f prime x, and then to f of x. It's going to be a lot of work. So for this example, it's going to be f double prime x equals 6x to the fourth plus 5 to the x, 5x plus cosine x. And we're given that f prime of 0 equals 2 and f of 0 equals 8. So f prime of x would be 4 plus 1, which is 5, and then constant over n, so it's 6 over 5, and then plus 5 over 2 because the n is 2, and then antiderivative of cosine x is sine of x, and then plus c. And now we're given that f prime of 0 equals 2. So we're just going to write down right here. And now f prime of 0 is going to be c. So f prime of 0 equals c, and then f prime of 0 equals 2. So we just set this equal to each other, which is c equals 2. So we're just going to replace this with 2. So the antiderivative of f prime of x is f of x. So we just do the same thing. So antiderivative of sine of x is negative cosine x, because derivative of cosine x equals negative sine x. So negative cosine x would be negative of negative sine x, which is positive sine x. So this goes over right here. And then plus 2x, because we know that the constant is 2x, and then we just add x to the x. So it's 2 times x. And then plus d. This is like another constant, or like c2, because we have to use another letter so that we don't get like confused. So now we're given that f of 0 equals 8, and then f of 0 is also d. So we set this equal to each other, so it's d equals 8, just like how we did over here for c. And then now we just replace this with 8. So the final answer, or we just simplify f of x, it's 1/5 x to the 6th, and then 5 over 6 x cubed, and then negative cosine, and then 2 of x, and then plus d, which is 8, so it's plus 8. So this is the final answer. Thank you.